So try to understand what is interface segregation principle today using Golang. See like what is interface segregation principle. This is one of the principle in solid principles. Basically, what it says is the no client should be forced to depend on a methods it does not use. Meaning the client whatever it uses just give that particular methods only, don't give extra things. That is the meaning of this principle. In Golang you can implement this one using interfaces, and also you can define a contracts and adhering to interface segregation principle involves creating the fine grained and specific interfaces tailored to the needs of the clients. Okay, interfaces will be the way we can use and implement here. The key points of ISP are client specific interfaces. Okay, this is what we told, like whatever client want that only we will give, not more than whatever client needs. So interfaces should be client specific, meaning they should expose only the methods required by the client. Large interfaces should be split into smaller and more specific ones. Avoid fat interfaces. Interfaces with a large number of methods force implementing types to provide unnecessary functionality. This can be lead to a situation where clients depend on methods they don't need. So that we need to avoid. And minimal dependencies. Clients should depend only on the interface and methods that are necessary for their use cases. Avoid imposing unnecessary dependencies on clients. Okay, these are the three key points we need to consider while implementing a interface segregation principle. How we can implement ISP in Golang? As we told, we need to use interfaces that are very small, focused, and created to specific needs. Splitting large interfaces into a smaller ones, allowing clients to depend only on the subset of method they are required. Okay, client specific interfaces. Create interfaces that represent a specific set of methods needed by the clients. And composition over inheritance. Use interfaces as contracts to compose behavior by embedding or including interfaces within other interfaces. So these are the things we need to follow. So for now, what we will do is we will try to implement one simple interface segregation principle. What we will do is we'll implement a printer which with the basic printer, and we'll try to give the scanner, and also we'll try to see how we can extend further. Okay, for the different purposes. Okay, okay, cool. So okay, I think let us yeah, let us create new folder called interface segregation principle ISP. I'll create one main method here, main.go, sorry. Okay, in this one with package main. Okay, so as I mentioned, right, we will try to implement a printer method which will support basic functional like printing a document, scan a document, and fax a document. These three things will define in a printer interface. Okay, printer defines contract for a printer. Okay, it will be like a type printer, and it will be interface which will have methods like a print document, and it will take a document, sorry, it will be take doc of type string. Okay, and the second one is what we will do is we can try to scan a document. This is one more method, and one more thing is fax a document. Okay, these three things we will define in interface. So what we will do now is we will try to implement a basic printer actually. Okay, this is one of the interface. Suppose one uh, This is the basic printer. Whoever want to use these clients can use the basic printer if they want. Okay. Okay. So we will just try to split this one with basic printer defines a basic printer with essential printing functionality. Okay. So what we will do is type basic printer of type interface and which will just print into document. It will take just a string. Okay. So now we will define one more interface just to scan purpose. Okay. Scanner defines a contract for a scanner. Okay. So now what we can do is type scanner interface scan document. Okay, and one more interface will separate it for fax machine defines a contract for a fax machine. Okay, this one will be type fax machine of type interface and which will have a method called fax document. Okay. Okay, now we have this one, right? Now what we will do is we will try to um, we will try to create a one printer. For example, I will try to create one printer, basically any type, actually one type structure. Basically what we will do is um, printers, some medium printer. Okay, what name we can give for this printer? Mm, 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 mm. Printer names. Okay, so what I will give is now ISP printer. This will implement means, for example, basic printer and scanner interfaces. Okay. ISP printer will be implements both the basic printer and a scan printer. Okay, the scan interfaces. Okay. So how we can do that? This is actually struct. Sorry for that. Okay. Yeah. So now what we will do is we will try to implement func uh, ISP. I can say printer. I can suggest printer. Okay. Okay. This is of type ISP printer, and this will be like a print document. Document we are trying to take this interface from the basic printer, which actually takes doc of type string and returns nothing, right? So what we will do here is we'll try to print empty dot println printing doc. Okay. So this is the we are trying to override for this ISP printer, a basic printer also eligible. And also what we will do is we'll try to implement the function p ISP printer for the scan document also takes nothing actually. And what we will do is we will try to println scanning a document. Okay. Okay. So these two things are done now. Now my question is, how can we try to uh, give it to the clients actually, right? Client, we need to give the client also, like for example, one client, for example, suppose I need to create a function for the client. For example, this is the client. Assume that this is the client thing. Basic uh, printer client. Okay. So this guy just uses the basic client. Okay. BP basic printer. Okay. BP dot print document a basic printer client ENT. Okay. Assume that one more client, we have client B. Okay. That client will be is a like a medium level client. Okay. This is basic medium printer client. This actually takes basic printer and also scanner. Okay. So this guy will take both the things, and what we will do is BP dot. We can say that medium printer client and C dot scanner. Okay. So we can implement that facts also by suppose like a extended printer, for example, extended client you have, or like a premium printer client we have. For those particular clients, we can pass the three interfaces and we can try to implement that. That is, you can take it as a homework. For now, what we will do is we'll try to see this how we can implement this one. Okay. So now what I can do is I will just try to create the printer. Enter is equal to, I can say ISP printer, right? So now what we will do is we'll try to pass this one for the basic printer or printer. Okay. Okay, sorry, basic client. Okay, I will just try to call this guy, and also we can try to call medium printer client with if you see here we are just passing printer comma printer. Okay, let's see like let's try to implement this. Let's try to run this one now. Let's see the ISP. Go run main. Yeah, we are able to see, right, basic printer client and medium printer client, and it is scanning things. So basically here printer interface was initially being used by all clients, but it was split into more specific interfaces like a basic printer, scan printer, and fax machine interfaces. So here actually we have implemented uh, the ISP printer, which actually implements basic printer and scanner interfaces, right? This and client can be passed only interfaces they need. That is how actually we implemented basic printer client and medium printer client. So whatever they need, actually those things only we are passing here because here and here. Okay. So this is how actually we can expose client specific interfaces. Basically, if you see this, we are split it into three parts, right? This is the basic printer, but once we split this one, actually see it is very specific to the client specific things actually. Okay, let us refactor this one. I will try to refactor this printer.go package main. Oops. Okay. Now basic printer. I can split this one as well. Basic underscore package main. Okay. And then what else we have? We have scanner. Uh, s- Scanner.go package main scanner, and then what else we have? We have fax mission, fax mission.go package main. Okay, I am refactoring factor this one, and also I will try to refactor ISP printer.go, and this will be under package main. Okay, okay, and what else we have here? I think we'll try to implement this also with different. Okay, I will try to do this way. Dot go. Okay, package dot main. I will move this one there. Okay, okay, and lastly I will move this also too. I will move this one also. I will move medium underscore printer underscore client dot go package. Okay, okay. Let me rename this one with proper name. Basic printer client. Okay. So now we refactored this with a different way. Now you observe that I will try to run build this particular folder. You observe that there is a isp.exe is created. So now what I will do is I will try to run isp.exe. So these things are working as expected. Okay, so the basic thing here is we actually refactored the things. Before that, whatever we discussed, like the interface segregation principle using Golang. We are trying to expose the client specific methods, whatever it uses. And second thing, what we did is we have splitted the single purpose of the interfaces, and wherever we needed, we did the composition over inheritance. That is, the interfaces will be embedded within the interfaces that way. So basically, clients can, whatever clients require, those particular interface only will pass to the client to use that particular interfaces. I think overall, this is the uh, interface segregation principle.